Okay, so first I want to thank QCT, Richard and team, for building a wide gamut of a GPU server. So we are able to surface the market segment that demand GPU acceleration. Now just to recap, the market segment that we target, we focus on graphics. So there's a lot of gaming application in the cloud nowadays, design work, rendering, and also a virtual desktop, a virtual PC. A lot of graphics workload are moving into the server, a server room. In the middle, high performance computing. These are scientific simulation, financial modeling, all demand a lot of compute offered by the GPU. And of course, the AI, so I believe a lot of hyperscale customers here today, which are doing a lot of AI, deep learning training, deep learning inference, and also robotics applications. Now, with these market segments that we serve and the GPU products that we have, actually one of the very common question today is so which configuration should I pick? Which products? How many GPU in the server, right? That can give me the best optimal performance. So we want to take this opportunity today to share some of our recommendations. So for a lot of hyperscale customers, if you are doing a lot of deep learning training, that's a very important use case today, whether it's image, video, or a natural language processing. We definitely recommend our Tensor Core V100 GPU with NVLink that will give you the best performance time to solution. We have some more data in the following slide to show you. For more traditional high performance computing, simulation, modeling, so 2 to 4 Tensor Core V100 GPU, whether it's NVLink or PCIe will work. And all this configuration, we have QCT server available to service your needs. Now, there's a lot of popular applications on the graphics side, render farms and performance graphics. We actually have a server line products called RTX. 6000 and 8000 here, that is perfect for graphics acceleration. So the RTX product line, we have in the design hardware engine we call RT Core that accelerate a real-time ray tracing, and that can give you the best graphics performance. And just one more page on a few major use cases, a lot of mainstream graphics. We see a lot of movement moving the virtual desktop into the server cloud. Then we have actually low power, small form factor, a GPU we call T4. These are low profile, very efficient GPU that can service many users on the same GPU by sharing the GPU resource. For a lot of enterprise acceleration, we have many customers, industries coming in where they run a variety of workload. They want to do graphics, virtual desktop, but they also have data scientists do machine learning, deep learning, analytics and training. So the way that we would recommend is you have to look at your mixed workload to see kind of where's your priority. If the main priority for more graphics intensive applications, then an RTX product line will be very suitable, giving you the best graphics experience. But if that's the main workload is very compute intensive, a lot of AI training, building big models, our Tensor Core V100 GPU will be the best. But for many of our end customers, actually T4, we're just starting to use GPU, you want something that is not as performance intensive, but lower power, lower cost, lower entry point. A T4 is a very balanced solution. And as the earlier session today, there's a lot of movement on the edge. For more kind of edge deployment, doing video analytics or a machines that's outside of the server room, T4 is perfectly designed for that because it's low power and small form factor. And actually, we're seeing a 5G and telco, doing a lot of graphics intensive, virtual reality or augmented reality, on the edge too. Then our RTX product line will be very suitable for that one. So hopefully, some recommendations just to help you out, to select the best configuration based on your target use case. Now, I want to zoom in one of the kind of a major use case today, I think probably resonate with a lot of hyperscale customers here. It's kind of how to do the fastest AI training. So if you're doing natural language processing, actually one of the, if you use a big model today, easily, even with a GPU solution, it takes weeks to train the model. So we have a lot of questions kind of coming in, how should they optimize, how to bring the training time back, from weeks to days or even hours. So we want to share a few best practice that we have in this area. But just a quick kind of observation that we have. The deep learning, especially AI, is driving the computing demand growth. So this is the data from OpenAI. Basically, like it's driving like a 10x per year in terms of computing demand, right? So these are the desire for more computing power is growing exponentially. So especially like in many enterprise, like a faster time to train whether it's a language model or image model is become critical to productivity and innovations. So this is one interesting example. Like, so if you're in the AI area, like kind of like ResNet 50 is one of the very famous image classification model. It has 26 million parameters published about 2 years ago. But the field has advanced so fast that, like, there are new models from like Google, from Microsoft, from OpenAI. Now the latest model, like called Megatron, has like 8.3 billion parameters, right? So it's like a 300 times bigger model, such that like you can do more accurate prediction, more sophisticated like understanding on natural language, and therefore you're able to drive like a better business performance. So the model size are definitely like going up exponentially. Now with that, so we are user of AI ourselves. We also want to train and build like a latest model for our own use. So to solve this problem, we actually built a GPU cluster with like a 1,500 like a V100 Tensor Core GPUs. The unique thing is like they are all networked together to do a single training job all together, right? So we can, instead of taking weeks to train, so we can do a single training in just 1 hour by using 1,500 GPUs together. So we have basically 96 nodes, 16 V100 GPU per node, and every node come out like we have like 10, like 100 gigabit like networking connection. So I think Shankar mentioned earlier today in the keynote, like it's actually number 22 on the top 500 list. It's a massive computer, but it is a tool that is essential for the productivity of our data scientists. Now, like, so this data is shown before as well. Like, so if you run MLPerf, pretty much like we break every category, whether it's object detection, language workload like translation, reinforcement learning is the fastest on the AI record. The key is like we want to build this cluster ourselves so we can use it, we can optimize our software for it, and we can share all the techniques that we have with our end customers too, so you can also build your own cluster and you can also speed up your work. So the recommendation-wise, like kind of high level, like we strongly recommend using like an NVLink-based server. So NVLink is a high-speed GPU to GPU connection. So that's critical for AI type of workload. Instead of like a single node, like it's important to extend to like a many nodes. Like we recommend we're up to 1,000 GPU. Like they work together to train a single problem, right? And that's how you can speed up like the training at scale. With 1,000 GPU, like the networking connectivity like becomes very important actually. What we see is I require up to like a NIC to GPU ratio, right? 100 gigabit NIC for every 2 GPU. So if you have 8 GPU in a node, then it's critical to populate with more networking connectivity such that like all the networking can keep up with the fast compute of the GPU. And we also have a separate compute and storage network. So this is almost like a very classic like high performance computer like cluster. And also like leverage the latest MGC software. These are the optimized software stack that is on our cloud, on the registry. It's free of charge. We actually like refresh them every month. Every month, like we put in the latest like a recipe, the most optimized like library, driver, software stack. So as long as you use the latest like software stack containing from MGC, then you will get a lot more performance like as the time go by. And actually in 7 months, we improve like a deep learning like training performance by 80%. And it's free of charge, you just have to update for it. So a little bit more detail on kind of NVLink, just to, in case like you're not familiar, like so we have HGX reference architecture, and we have QCT is building a couple system based on that. The unique thing is like when you have an 8 processor in a system node, so not only we have the kind of the basic PCIe connection, that's kind of the industry standard, we also have the like an NVLink which has like a connection specifically dedicated for like between GPU to GPU. And the reason is like when you train a big AI model, right? What happened is like there's a lot of communication happen between GPU to GPU. And it's critical to have a special high-speed bus like to speed up those communication. And the NVLink is about 10 times the speed of PCIe bus itself. So we can use the NVLink just to focus on doing the GPU to GPU communication, while the PCIe bus is being freed up for the more like dedicated CPU to GPU like communication to set up the command to get the GPU to train. If you don't have the NVLink in the system, then all the connections, all the communications have to go through the PCIe, and that can severely slow down the system. So with the NVLink system, like we have some measure data, like it's just based on container available, like on the web. Like you can certainly replicate the results yourself. So this comparing like when you have 8 GPU with NVLink versus 8 GPU with just PCIe only, to kind of see like what is the speed up with an NVLink-based server. For the more like a modern workload, the larger model, like speech and NLP, language translation, like text-to-speech, actually, like there's a substantial speed up because as the model gets bigger, you have more GPU to GPU communication. Than NVLink, you will see more benefit with the NVLink system. So up to like 88% or even like 200% on some of the recommended workload, that just speed up your time to solution by 2 to 3 times. So that's on the server node configuration. And then like at the cluster design, like we actually have a white paper, recipes that like, on our web that can give you some guidance on how to design the cluster to be best performing. What we do on our side is like we take a server with 8 GPU, and then we populate with like a 400 gigabit InfiniBand per server to a directed switch. And then separately, we have another 100 gigabit like an InfiniBand to a separate switch for storage network. So that way, like there we have a network specialized in compute. Make sure like when all the GPU has to synchronize with each other, it can have the best like a networking performance and throughput. And at the same time, when the data is coming out from the high performance parallel storage going to the GPU, it wouldn't interfere with the compute networking. Right? So this is the best practice that we have found out that can help like really speed up like a large scale AI training. And then like one last piece, like just use the latest MGC software. It's very simple. Like this is a repository that we have like online. We have like 50 plus container like covering a variety of use case. Not only deep learning, like not only all the top framework like a TensorFlow, PyTorch, and so on, but also like machine learning, Rapids, open source, and also HPC as well. Besides the containers, which are like an optimized software stack, we have like many like a model training scripts, workflows, and even pre-trained model that you can use so you can get your work started very fast and then just become productive right away. And we pretty much like refresh like the containers every month and put in our latest and best optimization into NGC free of charge. And as long as you use the latest one, then you can get the best performance out of the GPU. So like one data here showing that like just in the period of 7 months, like so some of the model like the performance go by 80%, same hardware, but just by using the latest software. And as a matter of fact, if we compare like since we launched the V100 Tensor Core GPU to now, it's around like a 2 years time frame, the performance has go by 3 times on the same hardware. So it is critical to use the latest software stack so you can take advantage of our latest optimization to get the best performance out of your GPU asset. So I'll do a kind of a case study just to put that all together. Like, so BERT is a very like I guess state-of-the-art famous model. Perhaps like if you are in the hyperscale like cloud business, like you probably spend a lot of time and resource training the BERT model. It has a variety of applications like in natural language processing. It can be adapted very easily. It's the first one that had achieved like superhuman accuracy, and the model is so large that like it requires like GPU to do the inference. Otherwise, if you use a CPU server, it's just not able to offer you the like a real-time experience. Now, so with the BERT, like you can just like leverage our MGC repository. If you have a lot of unlabeled data, you want to train the model from scratch, then you can just get the model script from our repository. We have the model available, then you can just do the training. But many times, like if you don't have a lot of like unlabeled data, like you just want to start from a pre-trained model, we have it available on NGC as well. Then you can take that model and then just fine-tune the model based on your custom labeled data that is specific to your market segment, your customer base. Then output of the model, then you can use it for inference right away. So all the model scripts, all the learning examples, everything is on GitHub, like everything, all the source code is there. If you need help, like let us know, like we're glad to help you to point you to the latest like setup so you can use the hardware most effectively. And then in terms of like just a time to train measure result based on the resource that we have, if you use a single 8 GPU node, like even though like with 8 powerful GPU, just to train the model for one pass, it takes like 153 hours. So that's basically 6 days. But if you use like build a cluster, like and you use up to 1,000 GPU, like our recommendation, then you can take that like 1 week of training down to like 1.2 hours. So that's a substantial time to solution improvement. It's pretty much a linear scaling down. Like as you put more GPU, right, you double the number of GPU, you can cut the training time by half. And there's a lot of under the hood optimization that our team has put together to make sure we can achieve this result. So we are working in this area. You need more information, more guidance. We're happy to chat with you. Like we're just around in the conference as well. Okay, so just to I guess wrap up a quick takeaway. So right tool for the right job. Like if you are focusing on graphics, HPC, AI workload, depends on your target workload. We have a server recommendation guide, so you can pick the most optimal configuration based on your workload, so you can get the best performance per dollar for your use cases. And specifically, like for a lot of hyperscale customers, you're doing fastest AI training. Our simple recommendation, like focus on using NVLink server, like basically you have a few choices from QCT already. To speed up the time to solution, like build a cluster, like we will recommend use up to 1,000 GPU, right? So if you have high-end model you want to train, you don't want to wait for a week for the results to come back. So we have a white paper, reference architecture, and how to build a superpod GPU cluster, easily up to 1,000. We have a customer successful use case where like they follow our architecture. It takes them 2 to 3 weeks to like set up the pod, and then they can just go and make the resource productive right away. And then like the last simple thing to do is just use the latest like MGC software stack from us. So it has the latest optimized software stack released every month, and also we have examples and how to use the training scripts, the model and library as well. So you can just try out our examples and then apply it your own data set. Then you can have be more competitive like with the latest like AI technology. So that's all I have. Like if there are any questions, we are around and happy to like talk more. Okay.